says that we have a mass attached of a spring, and we know that the mass is 2 kilograms, and the mass it has a force of 20 newtons that make it stay like at rest in a position 0.2 above the equilibrium position. So we know that, and we have to find a lot of stuff. We have to find the constant of the spring, the frequency, the maximum velocity, the maximum acceleration, the energy, and the velocity and acceleration when the position is 0.3 times the maximum position. So we can do that with our formulas that are in our formulary. So first we are going to find the constant. So we know that the first is equal the constant times delta x. So we can solve because we have delta x and the first, so we can solve for the constant, and it's going to be 20 newtons divided by 0.2. And if we do this in our calculators, we are going to get 100. So 100 Newton meters is the unit of the force. So this is our first answer. So then we have to know the frequency. For the frequency, we know, well, in our formulary there's a formula that says the frequency is omega divided by 2 pi. And we also know how to find omega. So omega is going to be the square root of the force divided the constant divided by the mass. So we know all the incognitas here, so we can solve 100 divided by 2 2p, and we do this in our calculators. So it's going to be 100 divided by 2 2p. It has to be 1.12539. So we know that 1.12539 seconds is our frequency. So we have another answer. So faster. So the velocity, the maximum velocity, we also have a formula in our formulary to get. So the velocity, maximum velocity is going to be W times A. So you can also put acceleration. The maximum acceleration is going to be W squared times A. So we know everything here because we know area. Yeah, we know the area. Yeah, we know the area. So it's going to be, no, this is not area, this is delta x. Delta x, delta x. So we know that, and we are going to find frequency. We know frequency is 100 divided by 2, 100 divided by 2, and we also know delta x 0.2. So we do that. Because it's not the A of the area. I remember it. It's the A of the amplitude, and the amplitude is going to be our maximum position. And in here, the maximum position is going to be 0.2. So we can do that. So sorry, I forgot. It's going to be 0.2. So this one is going to be 1.41 meters per second. Is going to be our maximum velocity. Our maximum acceleration is going to be, it's going to be 100 divided by 2 squared times 0.2. It's going to be 10. I'm not sure. Okay, I think it's 10 meters per second squared, so it's going to be the acceleration. I think it's okay. And the energy, we know how to find the energy since physics 1. So we know that the energy is the sum of the kinetic, potential, and Q. But in this case, we don't have Q. And our kinetic energy is going to be the movement. And our potential energy, we don't have potential energy because we don't have difference on the height of the mass. The mass is moving horizontally, so we only got kinetic energy. And we know that kinetic energy is 1/2 mass times velocity squared. So we can can solve that. So we have the velocity, we have everything, so we can solve for that. So it's going to be 1/2.1441 squared. So if we solve this in our calculators, we're going to get that. It's going to be I got it. I'm not sure what velocity I'm going to use. Oh my gosh. Oh, but we aren't going to use this because we have a spring. So it's going to be 1/2 of kx squared. Sorry. I'm sleepy. 1/2, we have key and 0.2 squared. So we can solve that in our calculators. Now it's correct. I think so. Square. So it's going to be 2. And I don't know the units of energy. I think it's joules. So I will put joules. I'm not sure. So it's going to be another answer here. And we can find the velocity, the maximum velocity and acceleration when this. So we can use these formulas again. So we are going to use that. So velocity and acceleration. So it's going to be W is going to be 100 divided by 2. This is going to be 100 divided by 2 squared. And the position is going to be 0.3 times 0.2, that is the maximum position, 0.3 times 0.2, and we can solve that, and we're going to get the velocity and acceleration in that point, 0.3. Divided by 2, so this is going to be 0.424 meters per second, so we know that it's less than the maximum velocity because it's obvious because it's not the maximum. So this is going to be 30 meters per second squared, so it's also logical because our maximum acceleration is a launch part than that. And that's it.